everyone, and welcome to our webinar. My name is 𝗘𝗃𝗁𝗁𝗁, and I'll today be walking us through the newest entry into the PicoIndenter, the PI Envision. On the left side is the actuation side, on the right side is our sample side, and we'll look at some of the modular features here. So if I loosen up this set screw, we can see how I can move our sample stage back and forth in order to accommodate many different modules, like I'll talk about in a little bit. On this side, we have two individual stages. We can move this stage in the X direction, so laterally. We can move in the Z direction, so up and down. And then on here, we can also loosen this set screw here in order to look at our sample stage. It's a multi-sample stage here, so on the top we have our quartz. We can also accommodate a second one on the bottom, and then I can tighten this back up. If we look to the sample side, or the actuation side now, you can see that there's another set of stages here to move our actuator forward and backward to do the indentation. This is an intrinsically displacement controlled actuator, a piezo-based actuator. It's secured just by some 4 screws, like so. This actuator goes up to 30 microns, but we can also swap out for our mechanically amplified flexure if we need to do large actuations to 100 microns. On top of that flexure, we can mount our electrostatic transducer. So the one that we see here is our 10 millinewton low load transducer that would sit right on top of that flexure. And then we could also swap this out for a high load transducer for all those higher load applications as well, in this case being a 250 millinewton transducer. This connects similarly to the flexure, where we just have these 4 mounting screws on top here. I'm just going to finish screwing in now. And so the probe would mount right onto the end of this shaft here. And so now I'll show putting on the probe. That's a very simple process to put the probe on. I just need to grab this out of its holding tube. So the probe looks just like this. Sits in my hand, put it into our tip tool, and then easily screw this onto the end of the transducer. And now we're pretty much set to go. Let me just put this tube back together, and then I'll move our sample stage back up just to make it a little easier to contact the sample, and we're pretty much ready to go. So now that we've configured this for our base configuration and indentation, I can convert this to the scratch setup. So I'll just move our sample stage back by releasing that set screw, screwing it back on. That just gives me enough room to be able to remove the tip. So it's pretty much the reverse of how I put it on. I just screw it off with this tip tool, and then I'll just put it back in its protective sheath as before. So there's the sheath that just sits in this rubber tube, and then in its carrying case. And then I just need to remove this tip adapter that just allows us to put the tip onto this thicker shaft, and we'll see why in just a minute. And then as well, I'll also remove this sample holder since we'll need to replace that as well. So now onto the transducer, we now have this lateral force sensor. This just screws directly onto that shaft where that tip adapter was. That's why that needed to be removed. It just threads on here, and now it's pretty much ready to go. And the probe would just go on the end here. I'm not going to put it on this time. And this allows us to measure the lateral forces in both directions when we're doing some scratch tests, which we'll do in just a minute. And now I actually need a little bit more extra room in order to get our scratch stage on here. So I'll need to remove this set screw to put it into a different position so that I can move our whole sample side back just a little bit further. Just tighten that down. And now we can put our lateral scratch stage on here. So this just sits on the same stages. We have a sample on here now. Again, a single set screw, and then I'll just put it down to an appropriate height so that our tip would now be just across from the sample, so that if I move that in, you can see that it's pretty well aligned. I'll move it back. Again, this is just so that when we do an indentation, we can measure our lateral forces, so that if we're now moving our scratch stage in our X or our Z direction, we can now measure those lateral forces with this force sensor here. Now that we have this set for scratch, we can move this into the heating configuration. So we start by unscrewing this lateral force transducer that we had screwed in. That'll come off right here and set it aside. Then we can take off our scratch stage, again just the single set screw, and lift it off. And then we'll start getting the heating components set up. So first we'll get our cooling block onto the sample side of the stage. So this is just a dummy here, but it sits on the same stages, again with a single set screw, this time on the other side. But this, I say this is a dummy because essentially there would be some cooling tubes that connect to this copper piece here. But this piece here is where our sample heater would connect, so it would kind of just slide in right there, but I'll put this on in a little bit after I get the probe heater on. So on the other side, we'll put the probe heater onto that same shaft on the transducer. Again, a single set screw, so just slide it right onto that shaft. And then all the wires connect directly to this box on the side here. And now that now that the probe heater's on, we can put that sample heater on. So it slides just into the dovetail of this copper bit here, and then turn the single set screw to tighten it, and then it's set up for heating.